Hi everyone, how are you today? Welcome to my new channel. Today we're going to be talking about web filtering firewalls in general. And today we're going to implement a policy for web filtering that is usually essential to be placed in any organization, enterprise, or even a small company to protect the resources of the network resources of the company. You probably want to establish a policy where only practical and useful browsing can only be used in the company. Now, I have noticed through some of my clients that when they implement a filter, they don't implement it in the perfect way, the most practical way, because there are a lot of concepts and network technologies that in between and go through in the middle of this implementation. Usually it's easily and very natural to skip or accidentally not configure the web filter correctly. So today, through this simple presentation, I hope to present for you the correct and the most practical way to implement web filter. Keep in mind, this is just the implementation of web filter. There are other stuff that come next, which probably gonna be in a different video. So let me show you how this session is gonna be placed, how the traffic is gonna work. It's actually pretty simple, and we go through the details. So here is the deal. I'm gonna show you here what's my lab is about, my setup is about. It's actually really simple. So we have here the firewall, and like we have here the PC. So this is really easy. So here is Fortigate, and here is the client. And of course, to access the internet and to do browsing, the client sends the traffic to the firewall as its gateway, and the firewall goes to the internet. So this is pretty straightforward implementation. So my FortiGate is already active. And of course, remember, when you start dealing with firewalls, regardless of which vendor you are using, you need to take care of 3 points. First of all, your firewall should be active with an active license. That's essential. The license shouldn't be expired or having any issues. The second thing, you need to handle routing correctly and prepare the proper implementation. And one little point that is usually sometimes missed by early implementation, that you need to correctly configure the clock. I don't recommend use a manual clock implementation. I would rather go for an NTP through a trusted server, but it depends on your available resources. So never forget to configure the clock. So correct active license, correct clock, and correct basic network configuration. So these 3 points should always be in mind. So in my setup here is my Fortigate, and as you can see, my Fortigate has only 2 ports for simplicity. It has only one LAN port, which points to the client, and one WAN port points to the internet. And everything here is configured. I'm using the subnet for the LAN and using the subnet for the WAN. My PC is towards the LAN port, and here is a very simple idea. So my client here has the IP address of this and 10.100.0.100. This is towards the LAN side of the firewall. Outside to the WAN, it is using a different IP, which is configured toward my router that points out to the internet. So this is a very basic setup, and at this moment there is no other configuration for the policy or anything, nothing here except a very standard policy I'm using to reach the client behind the firewall. So this is just a standard or a basic setup because I am actually using this lab on Microsoft Azure. So maybe I can talk about this in a different video, but for now there is no other policies to handle web access to the client. Nothing is present. So my client now, if I access my client, which is a simple Windows PC, if I try to go to any website, like for example, Fortigate, there is no connectivity because there is no policy to handle this traffic. If there are no policies to handle traffic, it is implicit deny, meaning traffic will be blocked. And this is rule, which is general rule in every firewall. So this is really standard. So the first thing we need to do is to enable browsing through firewall. I always recommend to set up any kind of firewall rules in steps. This is always my recommendation. When you do any firewall policies, you should always go in steps, because if you do the entire policy one time, maybe there is an issue you have been noticing and it will make troubleshooting much harder. But if you do it in a gradual steps, it will be much easier to spot any problem in the way where you are implementing your final policy. So for now, I'm only going to enable or allow web browsing without any security restriction. Also, I would like to mention something very important. Web filter as a concept and a technology is the same among all other firewalls. So we are talking here about the technology and concept regardless of which vendor you are using. I'm here using Fortigate because it's very common and very mostly used by many vendors and enterprises. And I was actually asked to do it on a Fortigate, so I'm doing it here on this vendor. But the same concept and technology here applies on any other any other firewall from any other vendor. So let's enable web application web traffic first by going to my Fortigate and going to the firewall policy, and I'm gonna create a new policy, and I'm gonna give it the name to web traffic, for example. Incoming interface, the traffic will always generate from the LAN side and it always exit toward the WAN side. The source, well, usually you would select here the subnet that this policy is going to affect. I only have a very simple LAN PC. I have already created this entry in the address list to make it easy to add to every policy. So you need to actually create it in your firewall. All firewalls have this kind of address book or an address list to save addresses of endpoints, subnets, networks, whatever. So I have already added it, and as you can see, it points to one single IP, which is 10.100.0.10, because I only have one PC. In your condition, you're probably gonna need to add an entire subnet in this access list, in this address list. So this is pretty simple. And the destination gonna be all, because I need to be able to access anywhere over the internet. Schedule is always this is an always active policy, so you don't need to have this policy like active in certain hours on certain days or something. And the service is the most important section. Since I want to only allow browsing, I want to allow the common protocol, which is HTTPS. That's the most used protocol over the internet for browsing. HTTPS represents a TCP protocol over the common port of 443, and you can actually move your mouse over the entry here and you would see that it has a TCP protocol identification with destination port 443. This is essential to be entered here for browsing. The old port that was used for browsing before, which is 80, I wouldn't recommend that to be used. It is not secured because it doesn't use an SSL encryption using the web traffic. So right now it is better to keep HTTPS. Another protocol which is really needed here to allow browsing is DNS, because the client would require to resolve the domain names I type in the browser. Once I type in a domain name in the browser, it will need a DNS to resolve, which is already configured on the client. I have already added the public DNS of Google, and as you can see it here, if I go to the DNS I have configured on the client, going into the interface, now on the LAN here, which it points out to the firewall, if you see it, I am pointing into the DNS server of quadruple eights, which represent the public DNS of Google, which the client is using to resolve domain names into IPs. In your office or in your company, probably you would be having an internal DNS. So this should be pointing into your own DNS. If this is the case, maybe you don't need to put it in your firewall. But in my case, the client needs a DNS over the firewall. He needs to pass the DNS request over the firewall. So I am adding a global DNS here in my firewall. Sorry, a global service here as DNS. And now here is added. Hovering over the DNS entry, we would see this will allow TCP and UDP over port 53, which is a common port used for DNS requests. So any DNS request destined to anywhere, because I didn't add a specific DNS or any destination, the rule here is any request going to port 53, whether it's TCP or UDP, it will be permitted. This is needed by the computer so it can send its DNS request over DNS. And once it gets the IP he needs for the website, you will move on and go on to HTTPS port, which is 443. So I'm gonna accept, and I'm gonna keep these settings as defaults for understanding of all of these options. I'm gonna try to make another video showing some advanced options regarding these stuff because they are actually very important. I'm keeping security profile for now inactive just to make sure, as I said earlier, you need to do any kind of policy in steps just to make sure you're not falling in any issues. Log traffic. I'm gonna log all sessions just for this video to check what we are implementing. And eventually I'm gonna apply. So of course we are going to use NAT. So this is a client using an internal private IP. So it will be using the public IP of the WAN interface on my firewall. And I'm using the outgoing IP. So any client exiting the network will be using this IP. So I'm clicking OK. And now the web traffic here is listed in my firewall list. So it's originating from the LAN, going to the WAN, always DNS, HTTPS, accept, enabled. So if you refresh between options here, you would see that there is already traffic is being processed by this policy because my computer is probably trying to access the internet passing through these protocols. So let's test from my computer here. And let's go for Fortigate website, for example. Let's close this browser. And let's double check the LAN settings. Yes, it's pointing out to 10.100, 0.100. And the other interface here is for Azure interface. It doesn't have a gateway. It's not going to affect my work. This is how to set up and now the internet is opening. So now I have open a website pointing to HSBC Bank and everything seemed to work. Let's see if I can open Fortigate website. So now from my client, I can browse, and browsing is now totally open, no restrictions. And I can actually confirm this from my Fortigate here, checking from the dashboard and checking from the FortiView, which will show you the current active connections. So it will show you here the active connections. These are all active connections right now. And I open two sites, which are HSBC and Fortinet. And they are definitely going to be shown here. Here's Fortinet, the website I open. And I open the HSBC Bank, probably somewhere here in the list. Sometimes you may not see the exact name because it could be hosted somewhere else, but anyway, my computer here is active. If you close the session, you can see it here in the log in forward traffic, and you can see it here in the log. These are all the connections that has been closed. As you can see here, my client already sent a DNS request asking for something to go. So for now, everything is opened and no restrictions. So let's move on to the second step, which we will implement web filter. We're going to the section. First, before we implement the web filter, let's create our web filter profile. So we can do this from Profiles, Security Profiles, and we go to web filter. And here we create new, and I'm gonna call it, for example, work web filter. And I'm gonna keep it on flow-based. Flow-based and proxy-based has some differences. We will be discussing these options in another video. Of course, I have an active license here, so FortiGuard is ready. And I'm gonna block all of the content that are not suitable for work. Like, for example, social media, a highly consumable, bandwidth consumable sites, and of course, web and media kind of sites, games and entertainment. So let's do it quickly. So here is, for example, potentially liable. So let's take all of this section and block. Adult materials, so we're gonna block, of course, all of this section. Bandwidth consuming, so I'm gonna go for streaming for now. Peer-to-peer, which is like magnets and torrents. Security risk, already all blocked. Advertising, okay. Games, sure. And entertainment. Social networking, very important. Of course, this is essential. Instant messaging, web chat. Maybe I'm going too restrictive here, but I just want to show you how to do it. So before here we close, one of the most important things you need to actually block when you are dealing with web filter is the proxy sites. Usually they are under either proxy sites or tunneling sites. So let's search for it. Here it is, proxy avoidance. You always need to block this one because someone is not able to access a social media site because your policy is blocking it. He may try to use another proxy website. This is not a 100% sure that it will block a proxy access, but it will block most of the tries. So keep it blocked here. This is essential. I'm gonna keep everything as standard here. As I mentioned earlier, many of these options are actually useful, but I will be discussing and dealing with those options in a different video. So let's go with OK. So my policy here is created. Also, you have some default options here, default policies here, but you cannot edit these ones. You can only use them as they are, but you cannot do any edits. That's why I created a new one. So go back to the policy, firewall policy, and now I'm gonna edit my web filter here, edit my IPv4 policy, and go down in the menu, web filter section, and I'm gonna select work web filter. I'm gonna select here. And for now, I'm gonna keep everything as same and click OK. So now my web filter is active, and let's see the effect of the web filter. Going back to my client, and I'm gonna close my browser. The reason why I'm closing it, because I wanna end any active sessions. And when you do any change on a firewall, not just Fortigate, the changes will take effect on the new upcoming sessions. They will not have an effect on any active sessions. That's how firewalls work. So this is something you should keep in mind. So let's try now to see if internet is working normal. Opening a bank doesn't have an effect because it's not listed in my block list. So Pinterest here, I'm trying to open it, it's not opening and giving me some error. The error message from the firewall is not displayed correctly, and I'm gonna tell you why. But for now, the Pinterest site is not opening. Let's say if I try to open a social media like Facebook, for example. Here is Facebook. If I try to open the Facebook, it doesn't open, giving me some sort of this error. If I try to open something that is not blocked, for example, let me open something that is not blocked here from the list here, like for example, training materials that are available like Udemy. So Udemy is like, I know, one of the popular sites for online training, simple self-training. So everything here is active. And of course, when you try to open the most common site like YouTube, you are getting this error. So now you have implemented our filter over your firewall, and it seems to be active. So are you done here? Do you consider yourself done here when you're dealing with? Do you consider yourself completed the correct filter? Here is the issue. For many clients that I have dealt with, this is not considered a complete web filter implementation. And the reason here is quite interesting and complicated a little bit, but you need to know it because it's very important. The reason here why this web filter is not completely implemented is because the firewall is doing basic check over the website that you are trying to visit. Basically, right now, at this moment, when you try to connect to any site, both of the client and the site form what we call an SSL encryption, because the traffic between the client and web server must be secure. So at this point, once the tunnel is up, the SSL encryption is activated. The firewall cannot see the actual traffic. It can only see the destination IP and port and the domain name requested. However, the traffic itself that passes between the client and the web server cannot be observed. And the reason is obvious, because the traffic is encrypted and the firewall cannot crack or decrypt any kind of decrypted traffic on the fly. It cannot do it. Even a supercomputer cannot do it on the fly. So basically, when you access like Facebook under this web filter implementation, Facebook, the client requests the IPs that represent the Facebook, the IPs then sent to the firewall checks the IP against a list of IPs. That's what the firewall does. And when the IP shows up as it belongs to the Facebook, the web filter take action. So simply you are doing an IP match in this case. But the firewall is not actually seeing or reading any traffic or inspecting any traffic between the client and the web server. Yes, this will work, but it will not work all the time, because sometimes new IPs are added to the sites, which your Fortigate may not catch in the result, because these IPs come from a database at FortiGuard themselves. Sometimes the IPs are very new and they haven't yet been updated. This is one. Also, even if the site belongs to the blocked list, sometimes it may not be blocked because it hasn't been added in the section. It happens, well, most of the time. Is this only the problem? No, there are other issues also. When you implement the filter this way, you cannot use the other extra options on the firewall. Like what? For example, antivirus. You cannot use the antivirus in this mode. Why? Because simply, if a user goes into one of the permitted websites, like for example, Udemy, for example, or any other website, when he tries to download the file will be downloaded even if you have an antivirus active or even if you have a file restriction policy. And the reason is obvious. The firewall does not see this action. All of the traffic coming in and out is encrypted, and the firewall isn't seeing what you are doing. If you want to use one of the proxy options of the firewall, like for example, you want to add a banner at the top of the page, or you want to do a word masking or anything during the traffic, and at the end you cannot capture a copy of the traffic. So even if you are permitting the website, sometimes you might be wanting to copy the traffic itself and keep a copy at your proposal. This is sometimes useful if you are dealing with sensitive websites and you are dealing with a situation when you want to review what happened between the client and the server. These stuff sometimes are really useful. So for now, what you are doing in exact that the firewall is just checking for the IP address of the website you are requesting, and if it matches a list of the blocked website, it just blocked, but it doesn't inspect or see any traffic. So what if we want to implement a complete web filter in a perfect way? To do so, we need to implement or activate what's called a deep scan or full scan into the traffic between the client and the server, meaning that the firewall will actually see the encrypted traffic between the client and the server, so it can implement other options like I have mentioned a moment ago. So how do you do this and how it gonna work? Let me show you here how the trick is played. So I'm gonna do that in a very simple way. Let's say right now what happens between the client and the web server. Let's say there is a web server here at the internet. So here is the thing and how it happens. And now let's assume that this web server is permitted. So this web server is not blocked. So the clients send a request to the web server, and the request before the traffic start is an SSL request. The web server send back the SSL reply, including all of necessary informations and tools. One of the most important tool here or object is a certificate. The certificate which proves that you are talking to the real website representing itself, whether it's Facebook, YouTube, or whatever. And also it includes encryption keys and encryption tools. So if all went well, this SSL now is activated. So now you have a tunnel between these two, and the tunnel is active. And this is called SSL tunnel. From this moment, all traffic between the client and this web server is encrypted. And it can only be decrypted at the web server. And the reason is clear, because the web server is the only one who has the decryption keys. No one in between the client and the web server can have the decryption keys, even our Fortigate. So Fortigate, once the traffic is established and permitted, the Fortigate cannot see traffic inside. So if I go back for a second here to my client, I am opening the site, which is Udemy, for example, and this lock here is telling me, if I click on it, that my communication is secure. If I click on it, I can get to see the name of the website and the certificate who issued it. It is certificate and it's correct and it's validated. So this is how the encryption occurred between my client and this web server. And right now, whatever I do on the website, it passes on as encrypted traffic. So let's change this right now. Let's start deep scan and full data inspection. So back to my Fortigate, I'm gonna create an inspection rule, which is deep scan first, and I can do it here from security profile, SSL inspection. So these are the defaults. I'm gonna create a new one, and I'm gonna create it by the name of my deep inspection, for example. Now this one is going to be used by multiple clients, which are presented as the LAN side, and they are speaking to multiple servers over the internet. This one is different. This one is like the opposite, like protecting your own server, but we'll be using this one here. Now this option is the one which is required, which is full SSL inspection. This is the one we need. Now the CA certificate, which I will speak in a moment. And block certificate, block any blocked certificate. Untrusted certificate, block any uncertificate. If I'm visiting a site and the site I'm trying to visit is using an untrusted, block it. And keep everything as normal and inspect all ports for easy implementation. And I'm gonna keep invalid SSL block if I'm visiting a site who is using an invalid certificate block. So these are like the initial or the standard settings for my deep inspection. And I'm gonna click OK. Now it's created. Before I proceed, I wanna tell you what exactly happens here. Just you can understand what will happen here once I activate or implement my deep scan. So here's exactly what happens here. Now, my client will send a request heading to the web server, and the web server name, for example, YouTube or Facebook or whatever. Now, this request here is an SSL request, which is supposed to be sent to the web server. Now, since I have activated deep scan from the Fortigate will hold this request. It will not pass it to the web server. So the request was supposed to go to the web server, but it will not. The Fortigate actually hold it down here and doesn't forward the request to the web server. The next step here is that the Fortigate is actually gonna send another different request to the web server that you wanted to visit. However, the difference here is that this request is initiated as if the Fortigate is the one who wants to visit the website, not the client. So the Fortigate here is acting as if he is a web browser and wants to visit the web server that the client wants to visit. So it's actually the same as if this is someone who is opening his web browser and accessing the web server that was requested. So if the client wanted to request facebook.com, the request stops in here. Fortigate open his internal web browser and heads to facebook.com. The web server response to request came from the Fortigate, which is an SSL reply, and it forms an SSL tunnel. Now the trick is, as you can see, the SSL tunnel has been established because basically the one visiting the site is the Fortigate browser, not the client. So now we have an SSL tunnel here, which is established. Let me correct this. So SSL tunnel has been established between the Fortigate and the web server. And now the Fortigate and the web server are communicating together with an encrypted SSL. So what about my client? My client wanted to visit the web server. Well, here what happens. The Fortigate now responds back to the client with an SSL reply. However, the reply is actually coming from the Fortigate, not coming from the web server. And to make things a bit tricky, the SSL reply comes with a fake ID and a fake certificate. In simple words, the Fortigate replies to the client and announce himself as the facebook.com and also represent the certificate, which is supposed to be for the Facebook, but it's actually not the Facebook certificate. It's like the Fortigate is faking himself and telling the client that, hey, I am the facebook.com, and here is my identification papers and my certificate, which includes the encryption keys. Now the client receives a reply, and once it tries to validate these documents, the client quickly understands that this is a fake response and demonstrate or show you a display of an error in the communication and stops the request. Basically, clients or any web browsers at any endpoints can easily check the response of an SSL and tell if it's actually real, coming from the real server over the connection, or if it's forged or faked by someone in the middle. Understanding how this stuff works would probably require some understanding of how the certificate and SSL work. This is probably going to be a discussion for another video. But for now, the client can easily check for this, and it can tell that he received a fake documentation. So he stops the communication immediately and represent an error of security to the user. That's how it works. Of course, at this point, the client or the user sitting at the client is the one who's in control whether to actually accept these fake documents or simply reject them and do not go to the website. So let's see this on the client. So I have implemented the web filter with deep scan. And on the policy, we have enabled, no, we didn't enable yet. Let's enable it. So now we go into the web filter, and in the SSL inspection, we move on to my deep inspection, as you can see here. Now, one of the options that I spoke about earlier, that I can decrypt the traffic mirror. This is actually a new feature in Fortigate. It was actually available, but would require some additional configuration. But from here, since you can see all the traffic, you can send a copy of all of the traffic to an external analyzer. This is very useful. So for now, I am using my deep inspection, and now I should be able to do the technique I just spoke with you. From this moment, my Fortigate will step in between any SSL encryption between client and internet and use its fake documentation to allow the client to use my keys for encryption and decryption, so I can decrypt the traffic easily. So I'm gonna go down and click OK. So my deep inspection is now active. Let's go back to the client. Again, if you have if browser open, close it to end any sessions. Again, this is because any old sessions will not be affected by the change. And now let's try to visit any website. Let's try to go back to Udemy here, and you will be presented by this error whenever you try to visit any kind of website. If I go, for example, for Cisco, same and same error. Why am I getting this error? Because you are trying to visit Cisco, and when the client requested an SSL documentation and identification from Cisco, here is what the client received. The client here didn't receive a certificate from Cisco. It actually received the certificate from someone else who has this name, FGT, which is Fortigate, and a serial number of my device. So my Fortigate even is not trying to conceal his identity. It's like you are asking identity for someone named John, and the person in front of you give you an identity for someone who is named Dave. That's totally visible. So basically here, I am not talking to Cisco. The certificate presented to the client is not from Cisco. And this error here is a problem. Of course, the user here can select. Sometimes he can select whether he takes the responsibility or not. For this site, he cannot, because Cisco is a very, very common and known name. Some other sites, you're probably gonna get an option to visit the site. You can actually continue. All of these sites are actually very popular, so I don't think you will be offered an option to continue. What about, for example, Sophos, which is another vendor? Well, I'm not getting any activity here because no, I'm not able to communicate. What about a low stand, not very popular website that I can actually use, like, so I can show you the bypass option here. Exchange. This one is actually should work. As you can see, communication is not working correctly when you have started the deep inspection trick by the firewall. What about Patreon? Let me close this browser. I feel like he has hacked. It should present an error. So I tried to bypass the error, but the browser is not giving me the option. Probably by now, browsers and all kind of browsing applications don't allow to bypass. Some do, but this one is not allowing me the most updated version, whatever I try to communicate. However, the internet is actually working. For example, if I try to go back to banking websites, for example, it opens normally. And everything else, this one is not working because it's trying to use Bing. But if I go for Bing, is being blocked for some reason. So as you can see, everything's giving me this error. So how to solve this issue? Solving this issue is actually simple. Right now, as I have demonstrated here, your computer is receiving fake identification and fake certificate. So the easiest and fastest way to solve it is basically that we are going to manually instruct the computer to accept and agree on these documentations, even if they are fake. This is your own responsibility, so you can actually do it. So what we are going to do is that I'm gonna take a full copy of my identification papers from the Fortigate and implement it in the PC, in the client, and enforce my client to actually accept these documents. I need my client to accept them. So it's like I am, as an administrator, given instruction to the operating system or the browser to accept these fake documentation. And here how you can do it. You can actually go back to the deep inspection options. Here is one I'm using, and click on edit. Now go back down, and here in the section, which is the fake certificate that you are using, my Fortigate is using one of its local self-signed, self-generated documentation and certificate on its system. So I'm gonna download this one here and save it on my computer. Now I'm gonna take this certificate, take it like this, and move on to the local PC, the client PC, and put it somewhere, like in document. It's already here. Probably I did some testing. Okay, here's the certificate from my Fortigate. Keep in mind that this certificate is generated differently from every firewall, and actually generated the first time you create SSL. So make sure you are using the correct certificate that is pointing out to the certificate on your firewall. So now I have it here. Just simply right click on it, click install, and now you are presented. Install it better on the entire machine, regardless of which user, and select the place to be installed. And the place that you need to install it is the trusted root. This is the highest level in the architect of the certificates. Other sections are not on the top tree of the certificate list. So you need to install it here to make sure that this certificate will be accepted no matter what application or what level is being used on the machine. So click OK and click Next and click Finish. It will tell you that the import was successful. Click OK, and now you can test it right away. And again, close the browser first. It will not have an effect on any active sessions. Open up your browser, or any browser on the machine actually, or any application that uses this policy we have configured. It doesn't matter, unless the browser requests the documentation to be implemented in the browser itself. Some browsers request this, like Firefox, for example. Okay, so now let's try again. Go to Udemy here. And now I am at the site of Udemy. If you notice, I haven't got any errors during this browsing. And if I try to open any blocked site, for example, like YouTube, you are presented with the correct error page. Now you can see the correct error page here in the web filter, which you were not able to see it before. And the reason is this response comes back in the fake SSL tunnel. It wasn't possible before. Now Udemy is open. And now let me show you the trick. I am visiting the site of Udemy. If I click here, I am told that the connection is secure. If I click on it and click on the documentation and certificate, I am visiting Udemy here, but I am actually using another certificate for it, which is not the Udemy certificate at all. It is the certificate from my Fortigate. So right now, my Fortigate is doing this trick. He is presenting the client with a fake documentation. The client is accepting this documentation after we force it to. And we have two SSL tunnels on the side, one on the side of the WAN and one at the side of the LAN. The Fortigate right at this moment decrypt, encrypt, decrypt, encrypt. So now he can see the plain data between the client and the web server, because simply the Fortigate here is doing like a proxy between the two sites, between the two destinations here. It takes the traffic, analyzes it, then forwards the traffic to its final destination. Some people like to call this technique man in the middle attack, or man in the middle, because my Fortigate is actually doing exactly the same as this kind of hacking technique. It's presenting itself as someone else to the client, and the client is faked by it and using its fake documentation. At this moment, when you try to visit any website, except for some exceptions, for example, let's visit, for example, Cisco. Where is Cisco? Okay, here is a site of the global network devices provider Cisco. Again, if I open up the connection, and you will see here that the certificate is again the same certificate from the Fortigate. So this is how you actually and correctly implement the web filter. So at this point, your Fortigate is now able to see, inspect, and analyze all the traffic between the client and the web server. From this moment, you can do a lot of stuff. Any antivirus will be activated correctly. Any data leak protection will be activated correctly. Any data traffic recording or capturing will work correctly, because simply your Fortigate sees the traffic passing between the client and the web server. This is the correct way to implement the web filter, and this is the essential and more practical way to implement it. Of course, there are other options that we have seen while we were trying to implement this rule, and I'm gonna be discussing these options in another video of how to get the maximum of your web filter option, and at the same time you can actually save resources for and perform and keep the correct performance for your firewall. So I hope this video has been informative for you and for your enterprise, office, company. And I'm gonna be moving on to other options of how to actually use your firewall more practically and more friendly in your optimization for your network. So let me know if you have any comment in the comment sections. And really, I thank you all for your time and I hope I'm gonna see you again soon.